So we have this currently running on an Amazon AWS server, and the entire front end is written in React JavaScript. The main reason we use React.js is because of familiarity with the framework and for the way that it can easily fetch data and then manipulate that data. So here we have our login page. If a user goes to any other page besides the login page, they immediately just send straight back to this page. We can register a new user by clicking this button over here and creating our user. Then we must input our password and then re-enter it. And then we click register, and we've registered a new user. Now we can log in with our credentials, and as we can see, we've now logged into the website. So once we've logged in, we've got this view, and as we wait for our graph to load in, and here it is, we now have our entire graph. And we can stop the physics there so that we get a little bit of speed. Okay, so now we've got multiple options for our graph. We can either see the social network of the graph. All of these will take a little bit of time. But if we want to then filter this so that we've got less data to have to deal with, we can click on the side here and view a list of all of our, here we go, we can view a list of all of our employees, and we can choose two of them here and choose the shortest path between these two. As you can see here, we just click that. We can see now the shortest path between these two users, and we can click again to make that go away. We can then see the label propagation as well as the centrality of these two users and the derived social network, which will once again take a very long time to load in. Or we can press return all and view all the users that are in this graph database. So we can also then go to the top here and search for a specific user. Example would be Chris. We can load and we can see all the emails. We can see the total number of emails that Chris has sent, as well as the top 5 people that he has sent emails to. We can then filter this down to only be for specific months, and as there is no data between March 31st to March 31st, if we search, we'll get 0 results. If we then choose a very further date and time, such as the 2000s, we might get some data, but that might take a little bit of time to navigate all the way back there. The user can then also log out here by clicking this button, but we can first show that even if he stays logged in and he refreshes the page, we have a Java web token that automatically relogs him in. If he logs out, however, he gets taken back to the login page, and on reloads, he gets taken back to the login page again and has to then log in once more in order to access the website. Thank you, and we'll be moving on to the backend database, or backend server and data backend. Our Flask backend uses an API approach since this better suits our needs for React frontend. This is our app.py file that contains all our API URL points. Here we have a verify login function that accepts a username and password, checks to see if they've been entered, generates a token based on this username and password, attempts to log in the user, and if that is successful, then it returns the token as well as a true response, which then logs the user in. If not, we send them back a false response and tell them to enter the correct username or password. We have a verify token URL that accepts a token, checks to see if that token corresponds to a user. If it does, then we log them in. If it doesn't, then we return them to the login page. We have a verify register URL that takes in a username and password, checks to see if they've been entered, checks to see if the password is of the correct format, checks to see if the username is unique, then it creates a user with that username and password and returns true to the user. Else it returns false and prompts them with the correct error codes. We have a logout function that accepts a Java web token. Once that token has been entered, we then remove that token from the database and prompt the user or prompt the front end to remove that token from the user's profile. We have a search employees function that accepts their first name, last name, start date, and endpoint. We then search the database for a user matching the first name and last name, and then check all the emails sent within the start date and endpoint, and return the amount of emails sent as well as the top 5 email addresses sent to. We also have a getAll function that returns all the employees in our database, and this is mainly just used for visual aid for the user in order to help them with mainly the shortest path algorithm. We'll now look at the SQL API functions that we use to accomplish all of this. So here we have our relational database API file, where we have functions such as create user, where we create the user with the username and password, a login function that checks to see if a user with that username and password is found. We have a logout function that removes an auth token from a specific user's profile. We have a unique user function which checks to see if a username is indeed unique. This is our correct pass format function, which returns true if the password entered matches this regex expression. If it doesn't, it returns false. We have a getAuth token function, which looks for a user with the username and password, and then returns the auth token associated with that password. We have a checkAuth token function, which checks to see if an auth token corresponds to a valid user. We have a generate token function, which generates a token for a user based off their username and password, as well as a random salt added to that. Then hashes all 3 of these together, and then returns that key or that token. We have a getAllEmployees function, which returns all the employees in the database. A searchEmployees function, which accepts a last name, first name, last name, finish date, and start date. We then search in the database for a user matching these descriptions, and then get all the emails sent within that time frame. We then get the top 5 employees sent from that user, or sent to from that user. We also have functions for inserting employees into our database, which was used after we'd cleaned the data set and wanted to add all the employees to the data or to the database. This is all for our backend server, and I hope you've enjoyed.